we started off by kind of developing one of the formulas for the derivative of arcsine, arctan, arccosine, all those things. We did arctangent, I think, in class. In any case, the formulas for all those things are still in your notes, right?
Yes.
So I would like to see if you guys can handle numbers 2, 3, and 4. This will just be another touch on these. In a few minutes, we'll look through these examples, and then we'll be jumping into 5, 7. So take a couple of minutes here. Feel free to look back and forth. Keep in mind a couple of things here. With your schedule this week, this Thursday is your 5-4 to 5-7. Yeah, 5-4 to 5-7 quiz. And so we're going to finish up 5-7 today. That means your web assignment is due Wednesday night. What that also means is that on Wednesday of this week, we'll take about half the class and we'll do some review activities. We might even do some work at the board. I mean, really it depends. Here's what it depends on, Luke, and I definitely appreciate what you said. It really depends on this. Board races are no fun when people don't know what they're doing, right? So we got to make sure that we're practiced up. And so, because if I give you a question up there on the board and everybody's standing there like, I don't know what to do. It's like, okay, this is totally unproductive. So hopefully we'll be able to get you to a place where you're productive. We could do a review kind of like that. I think that would be fun to do. And then while you're working on those, one other thing that I'd like you guys to hear, I know that, I think it was this weekend, if it hadn't already happened, they opened up all the practicum signups. And I just want to tell you guys again, I know I said it earlier, if you're going to be in town for any or all of practicum, you really need to be here at the AP Calculus practicum. The reason being, a couple of reasons. April. If I were to boil down the success that we have had in AP test stuff, I think April is probably the number one reason. And of course, it used to be, prior to 2 years ago, most of you guys know this, prior to 2 years ago, practicum was not a thing, right?
Yep.
Just didn't exist. And so as you can imagine, it's like, hey, let's take 1 week and not do anything that week. As someone who had a system that worked extremely well, I'm like, wait, what? You're just, and you expect the scores and everybody to still do really well? Okay, interesting perspective, And so what we do, we basically keep the same schedule in April that we always have, which is we do a lot of practice tests, a lot of practice quizzes. That is the surefire way to get you ready. They'll all be graded. They'll all be for real grades, real tests, real everything. And practicum is a great way to load up for that. Okay. During practicum, we focus on free response questions. We'll do a lot of those. We already have done a lot of those, but we'll focus on those during practicum. And one of the very first things you will do when you come back is a quiz over free response questions. And it will be real and it will be for a grade. If you have gone 2 weeks and have done nothing, it has the potential to be extremely rough, right? But if you went to practicum, it has the potential to be not nearly as rough, right? It will happen the very first week you get back, okay? Not the first day, but the first week it'll happen. So you simply cannot afford to do nothing for 2 weeks and then show up and be like, all right, I'm ready for a, whoa, no, I'm not, right? So you want to be at practicum, okay? It's a very productive time. It's all good. So anyway, sign up. Yeah, go ahead.
I don't know what the format looks like. What is it? Is it like all day?
So no, the AP Calc practicum is from 8 to 10. It's every day, 8 to 10. And let me say something about that. One of the traps or one of the lies that people tell themselves is so it's like it's Monday through Friday, right? And let's say that for some reason you're only going to be in town on Monday and Tuesday and Friday, something like that. People will be like, well, I'm only going to be there for 3 days, so I just won't come to any of them. That idea. Each day is a standalone day. So if you can only come to Monday, Tuesday, and Friday, come to those days. It's not as if you missed Monday, Tuesday makes no sense. At that point in the game, we will have covered every single topic there is to cover. And so if you just show up on Wednesday only, because that's the only day you're going to be in town, that's better than showing up 0. Now, if you are going on a discovery trip, you're going to be gone. That's great. I'll be posting. I might already posted. If it isn't already, I'll post it. All of the material that we will be covering on practicum, save some warm-up exercises. Everything will be posted, and so you can do those things. Honestly, there will be large parts of those you should be able to do without help. Some of them you might need some help, you know. I don't know, I've been pondering trying to make videos of the practicum side, you know, like the practicum and posting those videos. We'll see how that works, I don't know. So, yeah.
So if you like miss like a day or two, do you have to make up the work? Or
No.
is it just
No, this is purely, yeah, I mean, like,
You should, but
Yeah, like
it's
you're
not
gonna need
graded.
to know the information.
yeah, like, it comes down to how well do I want, I'll put it like this, pay now or pay later.
Okay.
You want to pay now, then you should put in the work now. If you want to pay later, you're going to have to put in the work later or deal with maybe a bad grade.
So how long are the days?
You mean like they're 2 hours, 8 to 10. 8 to 10.
2 hours for 5 days straight?
Yep. So what we typically do is we warm up with some Kahoots and various activities, and then we get into the FRQs, and I'll post an FRQ, and you guys will try it, discuss, and we'll work through them all, answer questions, and we'll do another one or two of them, that's it.
Do you ever do like a full length practice test?
That's a whole different topic.
Okay, well I didn't know.
Sort
that's
of.
Not part of the.
That's not part of the practicum. No. Caleb, yeah.
Are the answers to the free response online?
They'll be posted along with it. They're solutions-ish. It's not going to have like annotations and like, here's why I did this. And so that's why a video might be better, because you could actually hear and see what's going on step by step. But at the very worst, a listing of a couple of steps and an answer will be on there.
Question. Is practicum the first or second week of break?
First. Yeah, it used to be the other way. Yeah. Okay. I think it could work out fine. I do. I think, depending on how diligent somebody is, it could work out really well. Yeah. All right, ladies and gentlemen, let's see how you did with number 2. Derivative of arctangent of 3x over 5. Hallie, what'd you get for that one?
Number 2,
Number 2.
I got it's mean over 25 plus 9x squared.
That is exactly correct. Where'd you get 15, by the way?
3 times 5.
Yeah, it's basically u prime times a, right? Okay, so looking around, you all had the formulas to look back on. Hallie has given us a good answer. Do you have any questions?
No, that's right.
Okay, I agree. Okay, number 3 is a little tougher, right? What do you think, Ben?
Oh, alright. I think it's 1/2 x to the negative half, all of that divided by square root of 1 minus x to the half. 1/2. Now, I don't know if that's in the right form, because.
Obviously, there's some stuff we could do, but we can at least judge whether this is good or not.
Okay.
What do you guys think?
What do you think?
You're getting some silence and a little frown from Alyssa over there.
X to the 1/2 squared.
Right there.
Yeah.
Should be x. Yep. So let's talk about y. If you look at this right here, your u is x to the 1/2. So I think you correctly identified that. And then a is 1, right? That's a little tricky because there's nothing written there. Of course, it's a denominator of 1. And then your formula for this derivative of arcsine, I'll put it like this: ddx of arcsine of u over a is equal to u prime times the square root of a squared, which we all agree with right there, minus u squared. And so when you square x to the 1/2, you just get x to the first. So I think it should be that right there, x to the first, we'll call it.
Alright.
Drew, question.
Yeah, if you were to do just minus x to the 1/2 squared in like parentheses, on a quiz or a test, would you take off points for that?
I'm fine with that. If the reason that you did that was simply to be quick, I think that's wise. If the reason you do that is because you have no idea how to deal with the exponents, that's very, very bad. Because in a multiple choice, you're going to need to be able to simplify that.
Yeah.
So you got to understand, you're like, why am I doing this? And if you have a good answer to that, then great. If not, you need to get a little help with that. Anybody else with a question? Fantastic. Finally, we've got ddx of arctan of x over 7. So Alyssa, what do you think that ends up being, or any ideas?
7 over 49 plus x
7 over 49 plus x squared.
squared.
Okay. What do you guys think? Is that right? Is it close? No frowny faces? I don't see any frowny faces. I see happy faces. Okay. Alyssa, I agree with you. That looks good. So, do you guys have any questions? So, so Spencer, you were saying, I missed, and somebody else missed too. Dixon missed, right? Yeah.
Yes, sir, yes.
This is a really fast,
Yeah. Change it.
10-minute review of kind of what the bulk of what we did on Friday. So, what do you think?
Yeah, it makes sense. I saw it. Yeah.
If you know the formulas, it's really just plug, and chug, right? That old thing.
Plug and chug.
We talked about in class, like where did one of the formulas come from?
Okay.
The reason why I did that is what if you forget, you might be able to derive the derivative. But if you can get them down solid, you're good. Okay. All right, so Spencer, Dixon for sure. Good. Everybody else okay?
Yep.
Okay, so we're going to shift gears slightly as we move into the next and final. This will essentially complete our skills with integrals that involve fractions. So here we go. These are integrals that, up to this point, we've never seen anything like this, right? Never seen anything like this. Let me do a little zoom here if I can. Let me do this. That's what I want. That's more like it. Okay. So up to this point, hey, listen up. Up to this point, whenever you've seen an integrand that's a fraction, we've either said, hey, we don't like fractions and we've flipped up or divided, or we've asked ourselves, is it ln? These are just a couple of different more forms. These will be the final two forms that we can actually deal with. So here we go. The key is to see the pattern, see the key elements, and we'll point those out a lot, and realize that the integral is going to end up being an inverse trig function. Shockingly enough, just like the ones that we got done differentiating 2 minutes ago. Okay? So we're just going to be taking what we did in 5-6 and trying to figure out how that could get reversed, leading back towards arctangent or arcsine or whatever. So the ones that we're going to focus on the most are going to be arcsine and arctangent. If you are unsure, how do you check these sorts of things, these integrals? Yeah, differentiate. So I'll just put a derivative right here. If you find the derivative, you should be able to go back and check. But all these things should work together in a nice circular flow. All right, so based on what you just did, let's see if you can recall what that first one, this one right here that I'm drawing the arrow towards, can you recall what that sort of kind of looks like?
Sine.
Doesn't it look a lot like arcsine? Like the derivative of arcsine? So, what does the tall skinny s stand for?
Integrate.
So, if the integrand is the derivative of arcsine and the tall skinny s really does mean antiderivative, then wouldn't the answer involve arcsine?
Yes.
Just be reversing it. So I would say that this equals arcsine of u over a plus c.
Oh yeah, let's see.
We're just reversing what you showed that you're pretty good at it. You quickly did those. It's a question of do you have the formulas down or not, but this is simply reversing what you just did. And then what does number 2 look like, the second one?
Arctangent.
Should look a lot like arctangent, yeah. So we'll write arctangent of u over a plus c. Those will be the two that we focus on. If you remember from before, arcsine's derivative and arccosine's derivative almost look exactly the same, don't they? How do they differ?
There's no square root.
No? Arcsine and arccosine. A negative, yeah. Arccosine involves a negative, arcsine does not. So that's why we do not do arccosine here, because we could twist all of these into being an arcsine. If it could have been an arccosine, we could turn it into an arcsine pretty easily. So we just focus on these two right here. So I'm going to do 1 or 2 examples with you, have you guys do a handful, and then we'll finish with a couple of different ones. So here we go. Let's do numbers 1 and 2 together, if you guys could flip ahead to those. Okay, so take a look at number 1. So if I can, as scary as this might sound, can I get in your head just a little bit and try to help you with what you might think about if you were doing a quiz or a test, or you're being assessed on this? Do you understand? So here's what I would think. I'm going to pretend to go through a struggle, see if you can identify with this. You look at this integrand, number 1, and you say, hey, look, it's a fraction. an important thing to notice. What is the thing that I've asked you to consider first? Say again?
Could you flip it first?
No, well, you could, but like I've asked you to consider something else first. ln. So ask yourself, is it ln? So what you're really asking yourself is the derivative of the bottom the top?
No.
It's definitely not, is it, right? Because the bottom involves that radical, and it's got a negative x squared in there. The top is just a 1. It's definitely not ln. Does it make sense that we could like cross that off the list? It's not natural log. The next thing is maybe we could take Noah's idea. I think this would be valid. I am going to erase all this because this is not right. But here's what you would do. You would write integral of 4 minus x squared to the negative 1/2 dx. And once you've done that, you still have to ask yourself the question, did Timmy mess up, right? Is the derivative of the inside the other factor? So what's the derivative of the inside? Negative 2x, and then you look at that other factor, and what's the other factor?
It's nothing.
It's nothing. It's technically 1, right? It's not there, but it's 1 times dx. But regardless, you say, all right, well, Timmy messed up, and he messed up really bad, right? It's supposed to be a negative 2x. It's only a 1. He's off by a factor of negative 2, which is no big deal, but the fact that he's off by x is a major deal, right? So prior to what we've just talked about on Friday and today, if you were to look at this, you could honestly say, I'm not sure that we can do this, right? Because we tried ln, it didn't work. We tried flip up to the top, and that didn't work either. So you might be tempted to be like, well, all right, it's simply not going to work. Up until today, that would have been true. But here's what we would do. We would say, well, you know what? ln didn't work. Flipping up didn't work. Now we got to reassess and ask ourselves, is there any way it could be arcsine or arctangent? Which one do you think it might be? Okay, now what symbol tells you that you think it might be arcsine? No, it's the square root, because aren't both of them fractions?
Yeah.
It's really the square root. You got a fraction with a square root down there. And so I'd want you to recall this and say, well, I know that the integral of u prime over square root of a squared minus u squared, that leads to arcsine, right? And so you look at that right there and say, hey, does that look like that might fit? Maybe it does. And to be sure, let's identify our u and our a and our u prime to be sure that it actually fits. So if this is going to be arcsine, let's see how it goes. What would your u have to be?
X squared.
No. It would have to be x, right? Because it's u squared.
Oh, yeah.
And so your u would have to be an x. What would your a have to be? 2, right? Because it's a squared. So it'd have to be a 2. And then based on what your x is, your u prime would have to be a 1. So for this to work, let's compare what we have over here with what we have for number 1. The top is supposed to be a 1, is it?
Yes.
It is. The bottom is supposed to be a squared, so 2 squared. Is it?
Yeah.
And does the u squared match up with the x? It does, doesn't it? So this is already perfectly set up for arcsine. And so you would take your u's and your a's and all that stuff and make it work. So you would say the answer to this is arcsine of your u value, which is x, over your a value, which is 2, plus c, and you're done. What do you think?
I think
Go ahead.
You don't need like parentheses when you do arcsine?
You could. I'll take it without, but if you wanted to put that around the input, that's cool.
Okay.
That's a good idea. Good idea for sure.
So it doesn't matter like with ln, you have to do the absolute value.
Yeah, you don't have to do that here. Okay, number 2.
like Timmy did something.
Well, so I see the 23. Honestly, if you got a constant multiple like that, regardless of what we're dealing with, that needs to get out, right? So I'm going to get that out of there first. So it's going to be 23 integral 1 over 4 plus 9x squared. And we'll start there, right? Get the constant multiples out, and then we'll deal with the rest. Okay, so maybe let's mentally go through this like we did before. It's clearly a fractional integrand. The first thing I would ask you to think about is it ln? So is the derivative of the bottom the top? No, it's not. In fact, it would need to be 18x, right?
Yeah.
And the fact that there's an x involved in the error means that it's not ln. If it was just an 18, then it would be. It would be easy to fix. It's not, so we got to move on. So if it's not ln, might it be flip up? So if you flip up, I'll erase this, but if you flip up, it would be this 4 plus 9x squared to the negative 1. There's like double issue with this, a double problem. First of all, is the derivative of the inside the other factor? It is not. But then if you try to do an antiderivative, even if you like kind of told yourself that it would work out, wouldn't you get negative 1 plus 1, which is 0, divided by?
0.
So we have a double issue with that. So it's definitely not flip up. So maybe you've already arrived at a good conclusion here. If it's not natural log and it's not flip up, it's got to either be arcsine or arctangent. Which one does it look like? Looks like arctangent. Now what tells you that it's arctangent possibly? There's no square root and it's plus. Those are two important things to notice. So if this is going to work out, then we've got to identify our u and our a and our u prime. So what's the u have to be? 3x, right? Because it's a squared plus u squared. So the u would have to be 3x. How about the a? 2. And the u prime? Would be 3, right? Because if u is 3x, then u prime has to be 3. So let's recall our formula. In order for this to be arctangent, it has to be the integral of u prime a over a squared plus u squared. So the top is supposed to be u prime a, is it? What would u prime a be? 6, but the top's a 1. So Timmy made a little mess up here, right? So the du is wrong. So what we would do, like we've done for a long time now, I would just say, well, times 6 divided by 6. Let's see that thread has been running through all of our questions since like section 4.5. All right, so then our final answer, we can immediately go to that. It would end up being 23/6 times arctangent of our u value over our a value plus c.
Wait, plus.
Don't forget the plus c. All right. So what do you guys think? That work?
That works.
Okay, so let me give you a chance to work this on your own a little bit. So why don't you guys move on to numbers 3 and 4. I'll be around to kind of just help you a little bit as we go. I think numbers 3 and 4, I'll check. So with number 3, you could run through all those possibilities. And that's, guys, one of the things we'll do on Wednesday is try to get you to think through all the possibilities. Number 3 is not ln because the derivative of the bottom is not the top, right? The derivative of the bottom would be 4x cubed. The top is just a lone x to the first. So it is definitely not ln. Flipping up will get you a similar issue. So it comes down to, is it arcsine or arctangent? What tells you that it's not arcsine? There's no square root. So the only thing it really could be is arctangent. And I want to point out that it is okay to flip the order on addition. So if you wanted this to fit the arctangent pattern a little more specifically, you'd write x over 25 plus x to the fourth dx. Seems like a minor thing, but it could be helpful to think about it like that. Now, if this is going to be arctangent, then we need to analyze the denominator here. And if it is going to be arctangent, what does your u have to be?
X squared.
It's got to be x squared because you've got x to the fourth would just be x squared squared. And what would your a have to be? And your u prime would therefore be 2x. Here's how I would encourage you to think about it. The top is supposed to be u prime a, right? So you look at the top is x. U prime a is equal to 10x. So there's been a mistake. And so the top needs to be multiplied by 10, and the outside needs to be multiplied by 1/10. Now that we've done that, the integrand perfectly fits the arctangent pattern, and we can jump straight to the answer of 1/10 arctangent of x squared over 5 plus c. And we're done. That work for you guys? Saw a lot of those. Those are good answers, a lot of those out there. All right, and then finally number 4. Number 4, we've got a constant multiple again. So that 5, I really think needs to come out. So I would write 5 out here, integral of 1 over square root 9 minus 16t squared. And again, I would strongly encourage you to think the T word and ask yourself, hey, could this be ln? Because it's possible you're gonna see all these mishmash together. It's possible you could make a bad call if you're not thinking. So, is it ln? Is the derivative of the bottom of the top? No, the square root really messes that up, and of course the t squared, 16t squared messes that up too. Flip up is going to get you a similar issue, but it could be arcsine or arctangent. What tells you that it might be arcsine? The square root and the minus, right? Yeah, square root and the minus tell you that. So it's going to be arcsine. Let's analyze a little bit and let's decide what our u would need to be. Can you guys tell me what would your u have to be?
4t.
4t, correct? And your a would have to be? And if your u is 4t, your u prime is just a 4. So I look at what I've got there. The top is supposed to be u prime for arcsine, and it's not. It's 1. So how do I fix it? Times 4, divide by 4. That's right. Multiply by 4, divide by 4. So my final answer would be 5/4 arcsine. Let's try that again. Arcsine of 4t over 3 plus c. So you all had a chance to work on those on your own, right? You kind of have a chance to try that by yourself. Did it go okay? Do you have any questions that I can help you deal with? Okay. So our final topic, I'm really curious to see how this goes for you guys. This will be a good opportunity for us to use some of those good thinking skills I was just mentioning. What do you guys see is maybe a good option to do right away, right at the start before we really think too hard? Get the 5 out. Yep. Agreed. So 5 integral 1 over x squared minus 2x plus 50
Whoa.
dx.
We have to factor, right?
Wait a second. That's not right.
So, let's do some thinking. It's obviously an integrand that's a fraction, right? Is this going to end up being an ln?
No.
What's the derivative of the denominator? 2x minus 2, right? Well, the top's only a 1, so we are way off, right? We don't even have 2 terms. It's definitely not ln. Does that make sense? How we can just be like, nope, not ln? Well, if you flip up, you end up with this. And this is another one of those like double bad things, right? Because you're going to end up dividing by 0, and the derivative of the inside isn't the other factor even at all. So, we think, all right, maybe it's arctangent, maybe it's arcsine. What do you think? Is it arctangent or arcsine? It sure doesn't look like it.
Don't say.
But it's really arctangent. Okay? Can I explain? I'll explain to you. There's an old skill that I know you've all done probably at least 3 times. Three different classes. So within each class you probably did it 40 times. So you've probably done this 100 times plus.
Factor.
Completing the square?
Say it real loud, whine and complain. Come on. So that is our method. So here's what we do. It doesn't factor. And if it did, we would do something else entirely, probably. Okay. All right, so guys, ladies and gentlemen, let me remind you how this works. I think you're going to find this to actually be a little easier than you think. So here we go. Here's what we do. We take the denominator off to the side, and we work on it. So I'm going to write x squared minus 2x plus 50. Step number 1, we're going to group the... hey, listen, please. Hey, you all grown, so that means maybe you don't remember this, so I'm going to show you how to do this. We're going to group the first 2 terms, and so the grouping it just looks like this. Put parentheses around it. So I'm going to rewrite this real quick, and I'm going to give myself just a little bit more space. So it's going to be x squared minus 2x. I'm going to leave some space and put plus 50 out here. So all I've done is just group the first 2 terms. I haven't really done anything at all yet. So then here's how you complete the square. You guys remember with your old, when you studied quadratics, it was ax squared plus bx plus c? So the a and the b and the c were the coefficients. Here's what you do to complete the square. You locate your b. What's your b here?
-2.
And here's what you do with the b. You take half of b, which is -1, and then you square that. So half of b is -1, squared is? +1. So that number that we just came up with, that 1 is very important. Here's what we're going to do with it. We are going to add it inside the parentheses and then subtract it from the outside. So what have I done effectively? Nothing. I've added 0, right? I haven't changed anything as far as the value goes, but I've definitely changed the form. Now that thing that you all were wanting to do a few minutes ago, factoring, now you can do it. Factor that the polynomial in the parentheses there.
X minus 1 squared.
That is correct. If you follow those rules with the old completing the square, you'll see that. And then 50 minus 1 is 49. So what we've done is we have completed the square, got it into a better form, and now check this out. I'm going to come back over here to the left. 5 times 1 over x minus 1 squared. No, you know what? Let me write it in the order that you guys might like better. How about 49 plus x minus 1 squared?
That works now.
Do you see the arctangent in there? U prime a over a squared plus u squared. So if this is going to work, what's the u value?
7.
No. X minus 1 is the function. It's all good. How about the a value? 7. And if u is x minus 1, u prime has to be what?
1.
Correct. So for this to be arctan, if you remember the little formula, the top, the numerator needs to be u prime a. Is it?
No.
What does it need to be?
Multiply by 7.
Yeah, we got to multiply by 7. So I'm going to go times 7 and then divided by 7. So I can then come into the answer here and write 5/7 arctangent of x minus 1 over 7 plus c. Woohoo! It's funny, they say that they're going to do less algebra, they're going to go more conceptual, and then their less algebra involves completing the square in. So I don't know if that makes sense totally. Question, Dixon?
What is the application for this?
So again, I've got 7 minutes left. It's like really bad timing. I think I'll give you the real brief answer here. One, was that somebody in this class or was that the other class? It was Ben. He asked me with like 2 minutes to go, when will he ever use this? So, there is an answer. One of the direct answers is, do you guys remember? Yeah, telephone lines. They form what's called a catenary shape when they dangle. It's not parabolic or hyperbolic or something like that. And you can use arc tangent, arc sine, arc cosine to describe the shape of that. Do whatever you need to do with it. So I mean, that was like an instant explanation of what it could be. I would encourage you, if you really are curious, look in your book in this section, and I think you'll see a couple of interesting applications. Or Google. Say again?
Does calculus exist for telephone lines?
Would it exist if not for telephone lines?
Yeah.
Oh, probably, yeah, because there's other stuff too. Just a simple one. All right. Let's do one more. Can we do one more? Or was it another,
This was just a general.
What's 5 is, as you can see, just a touch different. What would you do first, though? Before you complete the square, you got to get the 3 out of there, right? So get the 3 out. Is today the 30th?
Yes. Crazy, like, tomorrow is.
No, there's one more day. 31.
Then Wednesday, Thursday.
That's true. Okay, so here's what we do. the 3 gets to come out of the integrand, and we get this deal right here. Like so. So and I would encourage you again to think about what you might be thinking about on a quiz. You would look at this and say, hey, it's a fraction, could it be ln? Doesn't the square root really mess up the ln?
Yeah.
And the fact that there's 3 terms down there and the top's only a 1, I mean, there's a lot of reasons why it's not ln. And similarly, there's a lot of reasons why it's not flip up. But you could look at this and say, well, I don't think that it's arcsine or arctangent either. But if it was going to be arcsine or arctangent, which one would it have to be? Because of the square root. So what we're going to do is we're going to complete the square. So here we go. This will be a little more interesting. Your thinking caps will have to be put on just a little tighter. Here we go. We're going to complete the square. And here we go. Negative x squared plus 4x plus 77 is the expression inside the square root. We'll put it back into the square root when we're done with this. But we're going to do the same thing we did before with a little twist. We're going to group the first 2 terms just like we did before. But this time I want you guys to remember that you cannot complete the square unless the a value is 1. So what we're going to have to do is we're going to have to get rid of that negative. And here's how we do it. We just factor it out. So it's going to be negative parentheses x squared, I almost messed up, x squared minus 4x, leave some space, plus 77. So once you've grouped the first 2, just factor out the negative. And now let's go ahead and do that whole routine with the b. What's the b value?
-4
And we take that -4 and what do we do with it?
divided by 2 squared.
So half of b is -2. And like you just said, we square that. And what do we get? 4. So here's what we do with that. We take that 4 and we add it. Please don't get too far ahead of me. We add it to the inside right here. But now we got to be ultra careful because we didn't really just add it. Right? Because isn't there a minus sign on the front of those parentheses? We truly just subtracted it. So in order to balance out what we just did, we need to add 4 instead of subtract 4 from the 77. So this is the one you got to be really, really careful with, the positives and negatives. It would be easy to not see that. And then we factor the first one, so it would be negative x minus 2 quantity squared when you factor that. Plus, hey, look at that, a perfect square. It's almost as if someone designed this question to work nicely. Wow. Yes. Then how we finish this off is we just take that expression and put it back into the integrand where it belongs and try to work it through. So it's going to be 3 times the integral, 1 over square root. I'll write it in the order that we're more comfortable with. 81 minus x minus 2 quantity squared. And now finally we just have to identify our u prime, and our a. So what do you guys think the u would need to be?
X minus 2.
It'd be x minus 2. Yep. How about the a value?
None.
And finally the u prime would have to be?
1.
Now earlier you guys proposed that if this was going to be arcsine or arctangent, it would have to be arcsine. So the top needs to be u prime. Is it?
Yes.
It is. So we don't have to make any adjustments. Timmy didn't mess up. You didn't mess up. We finish it up by writing 3 arcsine of x minus 2 over 9 plus c. Finishes with a little bit of a kick there, right? The old completing the square. Don't you guys agree that that's like kind of the easy version of completing the square? It's just doing the little thing with the b, and just we don't even have to like solve for anything like you guys did before, like with square roots and all that stuff. So hopefully that's all good. Good work today. We are done. One note, 6-1 video for Wednesday. Please bring the chapter 6 notes with you. We'll do a little bit with those, okay? 6-1 intro video for Wednesday. And I'll see you then. Hope you have a great day.